Swayam Prabha. Digital India. Educated India.
So, last time we started some discussion on a new method of printing, which is inkjet printing, and so we'll continue with that for a few more hours. So, in summary, we tried to talk about what is the place currently of digital printing. How do we differentiate between digital printing and analog printing? Difference between the spot colors and the process colors, and some of the very basic steps which are used in digital printing. And we realized that for various reasons we may require pre and post treatments in this digital printing method also, because the chemistry of the fiber and the chemistry of the dyes have to be matched. So, we continue further, and now we say inkjet technologies. Now, digital is one word which means that you are sending signals, pulsating manner, either there is something or there is nothing. So, 0 and 1, that is the kind of information if you keep giving, that's the digital part of it. But inkjet is the one which we have seen has been commercialized. The other way of printing paper, for that matter, is the color laser jet printer. But color laser jet for textile is not there. So, we are looking only at inkjet. Inkjet means there is a solution of a dye. It may have some viscosity modifiers, and it's called ink because the viscosity is less, and so you put it out of some jet and then it goes to the textiles. So, inkjet printers for the paper are pretty well established, and the basic principle still remains the same. The only thing that may change is because now you are not dealing with a material which is very smooth, it is undulated, surface is not so smooth, the material may be very wide, and expectations from the ink may be very different. So, in principle what you are looking at, you are supposed to create droplets and throw it onto the substrate, which is in our case textiles. So, droplets can have different colors to create photo quality image. Now, the position of the droplet has to be controlled, possibly at a very high frequency, because large number of droplets have to be produced in a very short period of time. So, when we talk about frequency, we are really talking about high frequency. So, all that information has to be sent through various transducers to the jetting area and the nozzle, and then there has to be a mechanism of continuous feeding, breaking the jet into droplets, and then we hope that there is an affinity to the substrate and there is a process post printing which can ensure that there is a fixation of whatever drops that have come. So, one thing which is very clear is we are looking at drops. So, general concept is any design which obviously is colorful design has to be separated. Like you had a normal design, an 8 color design, so you had to separate them into 8 type of, let's say, tracings, so that one tracing is for one color, and so you have so many screens or so many rollers, and so you push only one color through one and then superimpose the other. That was the way it was done in conventional printing. In this case also, maybe through a computerized way, you will still have to separate the design into colors. That is, one design based on one type of a color and the other design based on the other type of color, and all of them, when they get superimposed, then you get the final picture. So at least there are 4 colors that we are looking at, and so they must at least be divided into 4 different patterns. So if a different yellow or a different green is there, that means there are different combinations of these dots are present. And so, remembering the previous one, that the dots are not put one over the other, they are put side by side. And so where the drop has to come, some information has to be gathered. And how do you gather the information unless and until you separate? So therefore, there is a huge role of a software which understands color, divides also into colors, areas. Then within the area, it also finds between the 4 how much percentage of each one of them is there. Then you decide as to where you are going to be throwing the drop of which color where. So this is the first step which has to be done, and which is done. Only then rest of the information can come, because we are not mixing colors before. So every color is a separate entity, and that separate entity must be directed to a certain point. Only then finally you will see. So there is something called a print head, which has nozzles where the required amount of color would be present. Some signals have to come, and you have to control the drop size also. If the drop size is very large, then your eye can see different dots on the fabric. So they must be of such small area so that the eye cannot resolve them, should not be able to resolve. So you have to have small size, and that is also understood in terms of resolution. So when you have large number of drops in a smaller area, then you obviously are able to produce a finer print, and you call it better resolution. So when you say higher pixel density, means better resolution of every detail that is there in a picture. So that has to be controlled. So if done accurately, millions of shades can be produced. Now you are not concerned about how to mix, but because you are not concerned, and if you can actually ensure that the drop size is very small, it can be put in a very small area without there getting superimposed. Only the image appears to be a superimposed image and not the drop. So colors remain as thing, and so photographic image can be produced. Whether you want to produce a photographic image through inkjet is your choice. You may like to print the normal design with inkjet printing, no issues at all. But if this possibility is available, which was available in the paper printing technology, so the same thing can be done on textiles also. So like you have on a computer screen or an LCD projector, the pixels, the surface of a textile also in a way has to be divided in the same manner, and one can consider this area, the drop as a pixel. Maybe on this screen you may have still very large number of pixels. In a textile you may not be able to create that kind of a resolution, but you still have to use the same principle. Within the, if you have single color also, you can create many shades, again based on the resolution. What is the area in question and how much smaller droplet that you can make. Here this says the number of tones with single color can be defined or can be calculated if n is the matrix, like you have a 2 by 2 matrix, you have 4 by 4 matrix, a 16 by 16 matrix, 8 by 8 matrix. So area can be divided into matrices. So that is your n, and k is the shade or a color, either 1 or 2 or 3 or 4, and then plus 1. 1 means just white, you have added nothing, that is also a shade, right. So let us say we have 1 by 1 matrix and we have one shade only or a one color. So if you look at n square, it is 1 by 1 into 1 plus 1 is 2. So that is the maximum thing they can do. But if you divide the same area into 4, which can be considered as a 2 by 2, then you have 5, same area, because you have been able to reduce the size of the droplet. And if you have, instead of one color, at the moment white is not considered, the white is giving 1. But if you have more than 1, then you can create 9, because you have 2 colors or 2 shades. A black could be black and a grey. And grey means what? Grey also means that less amount of black, white was already there. So if you can create different shades with the same color because of resolution, then automatically shades keep increasing. And that is what basically is the principle that is used. So theoretically, if you have 4 by 4 matrix, the gray levels in a 4 by 4 will be 17, and if you have only 3 colors and not taking black also, which itself is a color, you can still produce number of perceptive colors is to almost 5,000. You get into the 8 by 8 matrix, you have gray for each color can be 65, because you can put one dot here, the other dot is bringing various kind of things you can do, because you are now resolving the same area. Higher matrix means you are going to be making the size of the droplet smaller. If you make droplet size smaller within the same area, then you can create 8 by 8 matrix can create 65 shades. And if you use all the 3 colors, you will be somewhere around 2,74,000 plus. And if you have 16 by 16, you are looking at millions. So as a principle, you can create any type of a shade as long as you know where to place the droplet, which is not easy, because you can't see it while it is happening. And so the controls are much more, the sophistication level at the machine and electronics is much more complex, and therefore the cost of the machine has been very high. And that is one of the reasons why it did not become so popular, while knowing that this actually is the best technology. You can do anything, and so, but anything also has a limitation, anything also has a limitation. Then you will not do a discharge printing here, you will not do a resist printing here, but you will be doing direct printing. So, if you are doing a light color shade and you think everything else on top can be visible, then it's fine. If you are absolutely dark colored background, then as I mentioned last time, you will have to create a white printing. Therefore, when you talk about 4 colors, now you can actually talk about 5 colors minimum. The white may also be a color which will also have to go and create a ground on a very dark background, and then you just directly print, everything should be okay. If it's a light color, you print directly. If it's a white, anyway you print directly. So, the advantage obviously is that you can print anything in a photographic manner. These days, if you go, some of the dress material, for example, are available in the market and they are called digitally printed. So, one advantage could be you may not have a repeat at all. Every time you are printing, the design could be different every portion. Computer way, you can actually say that after every this thing, you just keep changing. The colors can change, the design can change. You may say, well, one whole thing is only one repeat. Everything is possible. And so, considering that the interest has not died down, in fact, it has increased, that people now are finding that in case there are large orders they get, the cost of the infrastructure, which means space, machine, conditioning, could be compensated. So, the challenges still remain. Print head, which is the heart of the machine, which obviously must respond to every signal that comes, and the speed of printing also has to be seen, because finally the production also depends on how fast can you print. And so, this is also still a challenge. On a piece of paper, people are not so much interested. Now, when we talk about 1000 meters, 10,000 meters being printed, and people like that the speed should be high. Various kinds of electronic systems have to be built in. The head, which may be a very large piece theoretically, has to move quite a lot from one side to the other side, because the fabric is very wide. It could be 1.5 meter to 2 meter, depends on what's happening. And so, the heads must move large distances. The surface of a fabric is not smooth, and in case it just touches something, the life will be bad. Because while you are printing, you are just hoping that this will go and just stay there, and you will handle it at a different stage. The heads of the printer does not obviously touch it, but if there are hairs protruding out, things may not be good. Then the absorbency, of course, is there, but it should not be so much. The textiles have to be absorbent by nature. So, it should not be a situation where capillary actions can change the area where the impact was there. In that case, you will have an impression which will not be the same as you wanted. So, all these are there. The ink or the dye which is used for making an ink has to meet all these requirements. All these requirements means that you have only 4 and they must exactly be the standard. Their spectral characteristics must be exactly the same as, let us say, you see something on the screen, and so finally when they go and deposit, the drops are delivered, and then you see the whole picture through your eyes, it should look the same. So, any small change of any oxochrome in any of the dye will be giving you a different thing, which will not be called a standard. So, if you on a digital printing, Everything therefore became a standard. You cannot just say, okay, this also blue, why don't you try? Yes, you can try, it can be. But then what will come will not be what you want. And there is no correction here, It is printed only once. So good technology, print once, final. There is nothing to be done secondly. But then it has to be exactly the way one would have expected. Then unlike, for example, in the case of transfer printing, we were struggling to get to ionic dyes because there are so many fiber textiles that we use, and disperse can only go to polyester or some others in limited manner. But in this case, people also wanted that various classes of dye should be used. So you have reactive, you have acids, you have pigments, could disperse also. That means you are challenging. So this is a challenge. Now all of those dyes and classes must meet exactly the standard, which is, let's say, some electronic measuring system must approve. So not only it has to be pure molecule of a right kind, but it must be approved by the trisimulus measurements that yes, this is exactly what we wanted. If anything other than slight change means change. That's a challenge. So it's not that everyone is selling inks for digital printing. There are so many manufacturers for the textile dyes, but not for this. So that has been one of the things, because it's a very specific business. So inkjet printing, the general principles are that one is called the continuous inkjet. Now this has basically been designed for textiles, where the jet is continuously being generated. And then you do something so that wherever it has to fall, it falls, wherever it is not supposed to fall, it doesn't fall. Other is called a drop on demand, like you have video on demand. So whenever a drop is needed, the drop is generated, otherwise the drop is not generated. So there are two principles. Electronics behind the same, maybe same software may be the one which is governing everything else. So the principles appear easy to understand, but getting them done is obviously more complex, and so the cost and the sophistication still is part of this technology. Remember again that the print head does not touch the fabric. So every time it touches, you will have problem. That's the reason pre-treatment, not that bleaching and covering we're talking about, pre-treatment so the surface becomes a little more smooth so that nothing touches, because it can wrinkle, it can get skewed, all those things happen with tension, which does not happen in paper. It's much more rigid body compared to textile is a flexible material, and therefore this is important. Of course, it was important always in printing. You had to make sure the fabric doesn't slip. Here, of course, that's it. So we look at continuous inkjet principles. We are looking at principles. So piezoelectric system. Piezoelectric, you can appreciate, is a system which, or a crystal where you can get displacements by electrical input. And so if you call it a pump, so you don't have a pump of the kind that you can think in terms of pushing liquid into a trough in a padding mangle bath. So the pushing may have to be done by very small amounts. The small displacements and a controlled displacement can be done by systems like these. So this could be one of the important part of the whole thing called a head. So one interesting thing is that the jet is continuous, it does not stop. You may have a high frequency signal coming, and every time the signal comes, the jet just keeps coming. Continuously the drops are being formed and thrown. When they are being thrown, then we have to do something about it. So droplets are charged. So you can charge them. And sizes can be varied depending upon the frequency and also the total amplitude of the change. So if the amplitude change is less, so less amount of material will be pushed. So you can get, you still think what is the droplet size? You're looking at 3 to 40 picoliters, right? It's very small. So now you obviously therefore the control has to be good. In paper printing, they may be from 3 to 15, 20. In textile, in some cases, they wanted a larger liquid material so that it goes inside also. In a paper, you are only interested in surface. The textile has to be washed also. And so you want a bit of a diffusion, and therefore creating large displacement to get larger drop also was a challenge. So role of drop size we understand if it's something to do with the resolution. So smaller it is, better it result. What can charging do? If you have a big drop and it is charged, the charge normally like to reside only on the surface. But if same charge is there is between them at different places also is repulsion. If it was solid, the charge repulsion force is not high enough to break the solid. But when it is liquid, the charge can break it also. You have seen or heard about it at least, that nanofiber production. So there high voltages are used to produce a fiber, and if the voltages are of different ranges, you can get droplets, all right? And so there also droplets can be formed. But the charging is also used to deflect the material. For example, if suppose there is a reservoir and there is ink here all over, and through some push, you may like to push the thing, but as it comes out or very near, then you get the droplets get charged. The bigger droplets can become smaller, but once they are charged, they can be deflected. So the jet is coming continuously, head is moving obviously, the fabric may be moving in this direction, the head moves in this direction. So the drop falls. So wherever the drop is not required, it will be deflected to some other point, which can be, let's say, a drain. And wherever it is not deflected, so it just keeps on falling, right? And so it reaches a point, and then there is a textile substrate must be there where it gets deposited, and then you keep moving. It's called a binary because there are two operations that are happening. Either the drop is going to the substrate or it is going to the drain. So one or the other. So drops are produced continuously, therefore it is called a continuous inkjet. The drops can fall either on a textile fabric or deflected to a gutter or a drain. The applied electric field can charge as also deflect the droplets. There is something similar, as I said, like electrospinning or electrospraying. So one can always charge and make droplets of solutions. Careful control, of course. The jet velocity and the frequency of excitation. What is the frequency at which the jet is being thrown out would determine the size of the droplet which should be controlled with high accuracy, and this system of charging and deflection helps that process. You can imagine what we are talking about, a 3 picoliter, 10 picoliter, 5 picoliter kind of a drop size. Small stuff. So it can go from one to another. People have even thought of the droplet size a very small, you can put an air stream. A droplet which you don't want will just go somewhere else and the rest will fall. But then again it is pulsed. But this is one of the easier ones. But you can say, even as a principle, the now appears to be complex. First somebody is pushing, then the droplet has to be managed in the manner in which you want. Therefore, all signals must keep coming at the right points, the right time, and everything happens. So the gap that we were talking about between the surface of a textile and the printer head, if it is very large, so anything which goes opens out and is very far, it can spread. The drop can spread. If it contacts quickly, the size will be small. I mean, even if a small droplet. So in any case, whenever a drop is going to fall on something, it may have its own viscoelastic properties that can fall, come up and then go down. It's not like just goes there and deposits. You throw any liquid anywhere, it bounces back. So one has to worry about the viscosities in that manner also, but that's a chemistry part of it. But electronics is going to be something like this as a principle. So the other thing on the continuous inkjet system is a multiple deflection thing. I say, well, when you already have charged the material, reverse can also be done. That drain is going straight and multiple deflections can take to different points at the same time. One goes there, the second one has been deflected somewhere else. So multiple, that means more frequency, more drops getting generated. So one probably obviously thought maybe you can do a bit of a high production. Same inkjet is going at a different points also. In the first case, it was only at the same point where the jet nozzle was. Now the jet nozzle at one place, printing can happen at different places. Multiple means not 2, it could be 3, it could be 4. Only it's a question of deflection. So it gets deflected and also takes somewhere else. So that's the advantage in that sense. The waste in the case is going straight to the drain now. What could be the possible disadvantage in this?
Actually, the droplet size is less, small, very small. So we can produce a lot of finer sets. It means very accurate sets.
So that's the advantage. That's an advantage that the drop size was controlled there also, but we're talking about two different principles. One is taking continuously to the drain and keeping the right drops at different points. The first one was the right drops were coming straight, the unrequired, undesirable drops were going somewhere else. Size is different part of it. One of the things which you can probably think is the one which goes straight would have an impression of a circle. The one which goes further can become ellipse of different kinds. And so whatever resolution we are talking about, you may still be able to achieve, because eye may not be able to still resolve whether it is elliptical or circular. But what is likely to happen is the same droplet, somewhere it is circular, that means may occupy more area, where it is less circular will occupy more area, is more circular then will occupy less area, and therefore actually what you may observe may be slightly distorted. You may not still be able to find out. So within the same type of continuous, it's a pulsating system. Continuously means that for some time it produces some high frequency, and large number of drops, one after the other follow, and then there is a gap. Gap also is very small, but there is a gap. So that if you want to deliver more liquid at one place, that well, this want to be more, then more drops immediately come, but they are still small. They are all small droplets, and some are of course going to drain also, whatever doesn't go straight. So it's coming in bunches. Sometimes it was called also Hertz technology, because the person who proposed this was Hertz, a different Hertz of course. So the droplets are coming in batches, because you wanted more drops there. So liquid will be more. If you want less, only 2 will be generated. So it's coming in real pulsing systems. High frequency is required because you want lot of things happening at very small intervals and small droplets to be generated. So this is almost the limit is there. The 3 picoliter is the smallest droplet which is produced, and speeds are also pretty high. So they come in strike actually, and if you have 4 of them coming together, so there will be 12 picoliters. So at a high speed, high frequency, small droplets coming in bunches, so sometimes it stops and then again starts, so that kind of thing, pulsating. But otherwise still continuous, because continuously this thing is happening towards the textile. Whatever is not required is being deflected to the drain. Frequencies could be as high as 1 megahertz. You see, the electricity that we have here is 50 hertz is what we get. So we are talking about frequencies, we are talking about really high. But you still have to manage this. So another principle also people tried, instead of producing the drop by charge or another push, controlling the viscosity of the ink near the nozzle. So near the nozzle, you control the viscosity. So you can appreciate the viscosity of the ink is such, unless and until it is pushed, it will not come out of the nozzle. You see, on its own, you have to do something. So once something was being done there was pushing through, let's say a pump called a piezoelectric pump or something like that, and then charging and making it smaller and working it out. Now what it says is that this pulse will be there for jetting. There is an annular heater, annular heater all around the nozzle, and then it is heated in a pulse. So when you heat this, the viscosity goes down and then it falls, right? So now you can understand what are you controlling. You are controlling a temperature around the nozzle so that the viscosity becomes less. So the viscosity of the original ink is controlled in a manner that only this much will change and it will fall. And rest of the viscosity in the whole jet does not change. It remains the same only around the nozzle. And this pulse is periodic, jet velocity can be constant, and this principle also gives equal size drops. It's a principle. So they are called thermally excited continuous inkjet print heads. So interestingly, all these things are being used by one company or the other. So in general, because of the complexities associated with continuous inkjet, that you have to charge, deflect, and whatever has been deflected and gone into the drain has to be recirculated. It's a costly material you can't be throwing somewhere else. Some pressurization that you have to push continuously. These print heads are generally costly. So industry which are actually producing large amount of printed materials may be preferring this kind of technology continuously happening. Nozzles are, or the area around the nozzle, or what we call reservoir, is a positive pressured operation in this continuous inkjet. Operating frequencies of the devices which are put in this continuous inkjet category generally use higher frequency, at least an order higher than drop on demand, because there the signal and feedback has to be that this signal comes, the drop comes, then you wait, and then another signal comes, wait. If it is working at very high frequency, this feedback control system may not respond the way, and so they use frequencies which are slightly lower than them, but the continuous inkjet printing uses higher frequencies. We pick this up. A drop on demand means drop is generated only when it is required. If it is a complete blank area, let us say, you see, the question is that if suppose there is a design, there is some part of design, the rest of the portion is white. So what you are continuously draining, because that is not stopping. If it is very near, it's okay, but if there can be blank areas where you don't want any color at all, so that means continuously you are wasting the ink, or at least putting in the drain, and then you will recirculate after whatever you have to do. You may have to again at least make sure the viscosities remain same, flow properties have not changed, all that will have to be done. In this case, the drop will fall only if it is required. If it is only 5% of area being printed, I mean only 5% of the time the drop will be there, otherwise machine is stationary. But the process is not taking place. Head may be moving, but there is no drop coming out. So from that point of view, this obviously is a desirable technology. But if suppose 90% of the area is being printed, then it doesn't matter. Here also continuously the fellow will have to keep working, throwing it off. So one has to choose the technology with what kind of a technology you want. And there may be reasons why people use different technologies. So drop on demand, there is no deflection, etc. here. The piezo crystal may be, let us say in this case, put at the top of the reservoir and just pushes enough. It pushes enough so that same amount of liquid goes in, goes out, and the moment the liquid goes out, this goes back, and from other point which may be connected so that the more ink can get into the reservoir. So piezo crystals therefore are used as displacement tool by impressing, let us say, suitable voltages. If you have high frequency, these things are happening. So in this case, the frequency is so important that the production, if the frequency is very low, drop comes, and the waits for some time and drop comes, then your production is going to be slow. So you want high production, high frequency, but during that high frequency, that means such a small time, you are able to control, all signals have gone, materials happen. So here there is something else also there, that is called ink, which is a material. It is not, currents can pass through very quickly, but the material which is changing a property, which is now it is going to expand, okay, this is also very quick, then it must pressure the liquid so that the liquid just goes out. So you can only use certain level of frequencies, right? Because you want a response also. You know, if something happens very fast, let us say drop has not even moved out. Before the drop moved out, the pulse had gone somewhere else, right? It was pushing, it's gone back, and drop just could not move out. Then just be doing this oscillation. It must be enough so that it goes out and then you go back. So some control obviously. So it cannot be infinite level of frequencies that you may like to use. So in this case, the piezo system can be used in different ways. One of the ways in which it can be used is that you can put this piezo transducer anywhere, on the top, on the side. In this case, for example, there are 4 piezo sensors on the side of a reservoir, and there are multiple, so it squeezes and brings out. So what it means, multiple means, then you can produce more drops. The chambers are multiple, the transducers are multiple, and depending upon the need, if suppose in the same area everything is black, so all of them just fall in one go. If not, then selected will go. So multiple chambers are there which have the ink, and you have multiple side by side arrangements of various things within the same thing, and you can keep taking the ink out. So many other designs are also available, just like side by side, where a piezo attachment could be fixed and jetting could be done by pushing mode, by squeeze mode, by single, double, and so on and so forth. So principle remains the same, that the piezo electric crystal will change its dimension because of the voltage, and therefore it will definitely push, right. Piezo can do the reverse also, no? If you can put the pressure, it can generate current. It can be used as a displacement sensor, it can also be used as a pressure sensor. But important thing is very small amount of displacement. The displacements could be at the nano levels and very high. And therefore, the whole thing called a print head is a very small assembly doing everything. So we can stop here, and we'll continue from here next time.